In today's video, we are going to be implementing a basic library management system in which we are going to initialize the project, then create some CRUD APIs, and finally publish the project with implementing pagination, request validation, and finally implementing DTOs instead of returning entities from our endpoints. And by the end of this video, I hope that you are going to be much more familiar with the general concepts and architecture in Spring Boot applications. So without further ado, let's jump over to Spring Initializr. Actually, before that, I'm just going to show you the first task, which is to initialize the Spring Boot project for this particular system. Here we have a basic information for the project we are going to be building. I already have a MySQL database up and running on my computer, and this is the connection details, and we are going to be using some of those dependencies. And finally, we are going to create the basic folder structure that is pretty much consistent across all Spring Boot projects you are going to encounter in real life. Now, first things first, I'm going to take this task into the in progress column, and I'm going to jump right ahead to the Spring Initializr. And this particular web page is going to help us create a Spring Boot application from scratch. We are going to be using Maven as the project build tool. We are going to be using Java, and I'm going to pick out the oldest one available for the Spring Boot version. And here we have the project metadata, and I'm going to make up some group and artifact and description for this one, library and demo project for Spring Boot diaries, let's say. And we are going to be using jar. I'm going to go with YAML, but if you are more familiar with properties structure, you can go with it and be fine as well. And finally, I'm going to use the 21 version of Java. And the dependencies we are going to need is actually listed here. But apart from here, I would like to explain why we need them. So first of all, we are going to need the Spring Web dependency, which is going to enable us to create a web server from scratch in no time. And we are going to have access to certain convenient annotations such as get mapping, post mapping, request mapping, address controller, etc. So we are going to need that. And given that we would like to connect to a MySQL database, first we are going to need the Spring Data JPA as well as the MySQL connector, or also called MySQL driver. And last but not least, I'm going to take in Lombok, which, as you can see from the description, it helps us reduce the boilerplate code such as the getters and setters and various constructors. Instead of having like tens of hundreds of lines of getters and setters in a class, what we can do is that we can annotate that class with getters and setters or maybe data, as you are going to see during the project. And it is going to save us both time and it is going to improve maintainability in the long run. That is the key idea behind Lombok. So I'm going to go ahead and generate this project. So what I'm going to do is I'm going to get to my POM XML, which is the basis of my Spring Boot application, which stands for Project Object Model. And I'm going to go ahead and open that up with the IntelliJ IDEA that I have ready on my computer. You can also use Eclipse or Spring Tool Suite, but even the free version of IntelliJ IDEA is, in my personal opinion, superior, so I would definitely suggest you to use that. And right away, what you're going to notice is that even though I tried to open the POM XML file in IntelliJ, it actually imported the whole project because IntelliJ is intelligent enough to understand that this was a Spring project, in fact. So right off the bat, I'm going to go to the source file and I'm going to find this library application class, which has a main method in it, and that is annotated with a Spring Boot application annotation. And all of this comes out of the box so that we can just click on run. And in no time, in under probably 1 second, we are going to have I was going to say we are going to have a web server up and running, but that is not the case, and I'm going to now explain why. And the first problem we have here is that Spring Boot was not actually able to start itself because, as you can remember here in the Spring Initializr, we added Spring Data JPA as a dependency, and what it does is that it takes some connection parameters that we have seen here for an example and use those database connection details to create an actual connection for you so that you can conduct operations on your database, namely the CRUD operations most of the time. So before really anything else, in order to be able to see our application running, we are going to have to fix this failed to configure data source problem. And now that the first parameter it looked for was the URL attribute, it is printing a message related to that URL attribute. But our database application is protected, so it is eventually going to need the username and the password as well. So I'm going to go ahead and find the application YAML file under resources. And if you had picked out properties configuration in the Spring Initializr, which is also fine, you would have found here an application properties class, and the syntax differs slightly a bit. And here, instead of semicolons, you would have a single line with dots, but you can explore that on your own. So what I'm going to do is that I'm going to, okay, I already have a Spring definition, so I'm going to go ahead and add some data source properties. So I'm going to remove the empty line so that it doesn't look ugly and try to rerun my application. And yes, this time around, we have the started library application in 2 seconds log. What this Spring Web dependency we see here does is that now we actually have an application up and running, and not just an application, but also a Tomcat server. You don't have to understand the keyword Tomcat if you're a beginner, but basically what you're going to see here is that we are having some Tomcat web server related logs, and before just right before starting the application, Tomcat web server actually started listening on port 88, which is a fancy way of saying that we can access this application, we can access the endpoints, APIs of this particular application by typing HTTP localhost semicolon 8080. Now, that being said, I don't really want to go into too much theoretical detail. So what I'm going to see is that what we had here, and the acceptance criteria was that project is created, okay, dependencies are added, application runs, and finally we have the basic folder structure. And I'm going to create the 3 main packages that we are going to definitely need, that are controller, service, and repository. So I'm going to go ahead and rename this because I mistyped that. I'm going to say refactor rename and controller with double L. I'm going to create the package service and then finally the repository package. And with that, we are going to have completed the first task we have here. But don't get me wrong, the second one is definitely not going to last 5 minutes. So the next up, we have the major focus of this video. We are going to implement CRUD functionality for the book entity in this library management system. And we are going to have some fields in that entity, and we are going to be implementing repositories, service layers, and controllers, all that thing. In addition to actually having tested those, then we are going to earn the right to move this task to done. So first of all, I'm going to take this to in progress column, and I'm going to jump over to my IntelliJ application again. So the first thing we are going to do is that we are going to have to create a book class, or more particularly a class named BookEntity. But before that, I'm going to create a package named entity. And just as a slightly useful information, you don't actually have to create the package and then the class. What you can do here is that here I can say Java class, and I can say entity.bookEntity. And when I create this as a new Java class, what IntelliJ is going to do is that it is going to realize that entity is the package and book entity is a class that belongs to that package, so you don't have to do the same thing twice. So basically what this entity is going to, how it is going to serve us is that it is going to help us map database tables and rows into Java objects that we can use within our Java application. And at first, this is not going to be any different than a regular Java class that you can see any introduction to Java programming course. But then we are going to be adding some annotations, which is the usual way of interacting with Spring Boot, in a way that you declare your intentions so that the Spring framework handles the rest for you without you having to reinvent the wheel again and again. So I'm going to go back to the Google Chrome and see which fields we are going to have. And we have ID, title, author, and if I'm not mistaken, international standard book number. So at first, this is going to be resembling any single introduction to Java programming course you are going to see. We are going to have various fields, namely the ID, and I use long, but you can also use integer or string. Though this is the industry standard for relational databases, I'm going to have a title field, I'm going to have an author field, and finally we are going to have an ISBN field. Now, normally what you do is you create these getters and setters using your ID like this, but this gets unmaintainable over time, and this is just going to make your project less maintainable and less readable overall. So that's why in the first place we had imported this Lombok dependency, so that instead of this boilerplate code, we are going to be able to use some convenient annotations such as @getter, and as you can see here, this comes from the Lombok package. And here we have various annotations that we can use, such as data, getter, no arguments constructor, setter, and required arguments constructor, among many others that you can use and explore on your own pace. But for this particular entity, we are going to be needing the getters and setter annotations. And so far, this is just a simple Java class that, again, you can see in a classroom. But in order for Spring Data JPA, in order for Spring Framework to understand how it can work with this class, we are going to have to add some properties, and in a way we have to declare our intentions. Now, the first annotation that you're going to need to learn and maybe remember is the entity annotation that comes from the Jakarta persistence package. And if we are using Java 8, this is going to be JavaX persistence entity. But now that we are using Java 21, I'm going to be using the Jakarta version of it. And what this tells to Spring Framework is that, hey, we have a couple of fields here, we have a class here, but this is not a just random class. This actually is supposed to be mapping to a database table. In the database, we are going to be connecting. And the second annotation, speaking of tables, that you are going to have to learn and again, maybe remember, is the table annotation. And when using this annotation, you are going to have to specify a name that is going to correspond to the database table's name. Because if you don't specify the name of this table explicitly, now that our class's name is BookEntity, okay, this was supposed to be book, just to be clear. And now that our class's name is BookEntity, and if you don't specify this name value, what Spring Boot is going to do is that it is going to look for a table called book underscore entity. And if you are using a relational database and you are following the standards, this is not going to be the case. But for Spring to understand the table name book, you don't really want to name your class such as this one, because again, industry standards is like, we are going to have a couple of classes in this project, so this is not going to be a major concern, maintainability or readability. But in real life project, you have tens of hundreds of object models. So those conventions, the existence of those conventions, such as using asterisk entity, something entity pattern for the naming, is actually going to help you a lot, and in fact, your colleagues as well. So the third thing that we are going to have to remember is that every class that is annotated with the an entity annotation is going to have an ID field that is going to be annotated with the ID annotation, as the name implies. The variable's name is ID, but this doesn't make it immediately its ID. So you have to, again, declare your intentions to the framework. And secondly, you are going to have to use the generated value annotation if you're using, let's say, a relational database and you would like to use auto increment features, so that, for example, in a brand new table, your database application can create IDs such as 123, 1234, and so on and so forth. And you can, if you actually go inside this generated value annotation and go one step deeper, you're going to find the generation type, which you can explore on your own if you're interested. But most of the time, unless the specifications, project specifications are unique in your case, in your project's case, the automatic generation type, which is the default value for this generation strategy, is going to be more than enough. So for that reason, I'm not going to specify any generation types. And the last one we need to remember is that we are going to have to annotate other ones, other fields with the annotation column. And if I'm not missing anything, this is everything we need to do in this book entity class. Now, the next thing we are going to have to do is we are going to have to create a new repository interface with which we can access the related table and conduct CRUD operations using that repository. And I'm going to go ahead and create an interface. This one is important. And I'm going to name it, just for the sake of standards again, book repository. Now, what I'm going to do is to extend this interface, which is basically a way of extending the capabilities of this repository. And I'm going to either extend the CRUD repository interface, or even more sophisticated than that, even more capable than that, I'm going to use the JPA repository. And when you go inside this interface, notice that you don't have to be a Java guru for this, but you have to have a basic understanding of Java generic. And this repository has been implemented with two generic types. And in this case, T is the type that is your entity, that is the Java class that has been annotated with an entity annotation, and ID represents the class long in this case, which is the type of the field in that particular entity that is annotated with the ID annotation. So when I'm extending the capabilities of this book repository I have, I'm going to have to type in book entity, and then I'm going to type in long, because again, that is the data type of our ID in this particular entity. And before introducing the service layer to you, I'm going to start by creating a new controller and actually write a simple API so that we can use the repository methods to fetch and create data. And then we are going to touch upon why we need service layer, and then do the refactoring. So I'm going to go ahead and call this book controller. So in this Java class, we are going to have certain Java methods, again, the ones that you learn in the classroom. And we're going to annotate this class and the methods that is going to exist within this class with certain annotations that is provided by the Spring Web dependency. And this class, particularly the methods in this class, is going to help us create entry points to our backend applications. So before diving deep into the annotations, first we are going to create a basic Java method. And this method is going to be returning a book entity that will be retrieved by the repository interface we just implemented. And I'm going to call this method createBook. And although this is going to be ugly, at first I'm going to take a couple of parameters here, string title, string author, and string ISBN, which we are going to refactor later on in this video. I'm going to create the method body. And here we are going to need an implementation of this JPA repository, or more particularly this book repository that extends the capabilities of this particular JPA repository. And Spring Boot actually makes that extremely simple. What you do is you define a class variable. So I'm going to type private final book repository, and I'm going to name this variable book repository. And when I create the all arguments constructor for this particular class, we are going to have access to the functionalities of this book repository. And this is called, actually, this is the basis of dependency injection or inversion of control you hear when learning Spring Boot. What this basically means is that you didn't have to create and construct certain dependencies. Instead, what you do in Spring Framework is that you declare your dependencies, and then Spring handles them for you, handle the wiring, handle the infrastructural part that is behind the scenes. And right away, what you're going to realize is that I actually am able to use the book repository methods, such as the save methods, delete methods, and there are various types of them with different parameters and return types. We have certain find methods. And now that this method is called createBook, what I need, which the method I need is the save method. And as you can see here, it is going to take an entity object and it is going to return back to us. And this might not make sense to you much at the first, but if you do realize we have 4 fields here and one of them is ID, but when creating this book entity, we are not going to be setting explicit IDs. We will let Spring and database application handle them for us. So the reason the repository by default returns an entity object is that we can have the whole package together. So I'm going to complete this method. And now, as you can see here we are missing a parameter. So what I have to do is that I'm going to have to create a new book entity. And right away, I can actually say, okay, save this particular book entity. And this is not going to do anything useful because this is just an empty one. So I'm going to have to set the properties of this particular entity for this particular instance of the book entity class. Set author and author. And finally, we have the ISBN. And right off the bat, we are seeing some errors that we are going to go together. And yes, we are seeing the missing return statement error because in Java, this method definition is actually a contract between you and the compiler. I literally just promised the compiler that this particular createBook method, actually this particular createBook method with these particular 3 parameters is going to be returning a book entity, but I didn't use the return keyword. And if I try to say something like return 1 then, but then this is going to warn us that this is not the type it is looking for. And if you do remember when we had typed book repository save, we actually saw here that the repository implementation is going to be returning us an entity back. So I can actually say return book repository.save, and the compiler is no longer going to be complaining. But still, this is just a basic Java class with some Spring Boot dependency injection magic and inversion of control sprinkled in. But what we have to do here, just like when we were creating this book entity class, we annotated this class and the methods with certain annotations so that Spring can understand what we would like to achieve and then handle them for us. We are going to do the same thing here. First of all, we are going to have to annotate this class with the REST controller annotation so that the Spring framework knows that in this particular class, we are going to be exposing some REST APIs and the default return types must be JSONs and they should have a response body, so on and so forth. And secondly, we are going to have to either use request mapping or post mapping in this case, because that is the convention. The HTTP verb post is the convention when you are creating resources. And there are actually 2 ways to go about it. You can use the post mapping annotation or you can say request mapping. And then again, if you go inside this annotation, we have a request method enum here in which you have certain HTTP verb. So what you can see here is that this is called method. So you can also call this method request method post. But the one above that, the post mapping annotation, is just an easier, more convenient way of achieving the exact same thing. Last but not least, we are going to have to pass some sort of URI for our clients of this application to access this particular Java method. And I'm going to call this books by the REST standard. And if you're a beginner, you might be thinking, okay, why do I not make this create book or something along those lines? And this is actually a quite difficult question to answer if you're a total beginner. But if you are more interested in that, you can just, with the risk of losing you right now, you can just go ahead and research the REST architectural patterns. But again, if you're a beginner, if you're watching this particular video, I would just say either do it like this, or just trust me and call it books. And then later on, as you get more familiar with these concepts and piece of codes and annotations, then you can add on to these basics later on. That would be my suggestion. So if I try to rerun my application, what we are going to see is that, okay, I honestly wasn't expecting this application to run, because in most of the real life projects, what you have here in this YAML file is a property called DDL-auto update. And I'm just going to type that in right now and then explain what it actually is and what it achieves and what it is used for. I'm going to type in Spring JPA hibernate DDL-auto if I'm not mistaken. And I'm going to use the value validate. And if I rerun my application now, I'm expecting it not to work. Okay, that is in a way great. And if I scroll up a bit at the start of the error log, it says that there has been an issue with creating a bean with the name entity manager factory. And if you remember, entities has something to do with our Spring Data JPA configurations. And if I go a little bit down, what I'm going to see is that schema validation missing table book. And this particular problem is an important one, because so what we basically tell Spring Framework is that when getting our application ready to be up and running, validate our entity annotated classes and its fields with the ones that actually exist in our database. And if I go over to my terminal where I am connected to my MySQL database and I say select asterisk from book, what we are going to see is that this table, this particular table, does not actually exist. And there are two ways to go about it. Either you can create this table on your database and then try to rerun your application, or second, and don't use this if you are not prototyping. I'm going to use this because this is a demonstration project and I'm the only one working on this particular project, as well as I'm the only one who has access to this particular database. Instead of validate, I'm going to set this property to create. And now if I run my application, now this time around we see that started library application log. And if I come back to my terminal and execute the same select query again, now this time around we are seeing an empty set instead of an it doesn't exist error, which means that Spring Boot and MySQL hand in hand actually handled those missing parts for us. And this is not the only story. If I now say validate instead of create, what we expect this application is to actually run, because now everything is fine. But let's say if I make a typo here and instead of book, I say book, and I try to rerun my application, and although I have a book table in my database with these exact fields, what Spring is going to warn us about is that it was looking for a table called books, but it was missing. And same thing goes for the columns as well. If you make a typo here and put double E here, and in order to be able to get this application up and running, we are going to have to also fix that one and try to get our application running. Again, this is going to tell us that there has been some issues with the entity manager factory. And if I scroll down a bit, what we are seeing is that it again couldn't validate the schema. I mean, this time around, it found the table named book, but it wasn't able to find the column title. So by default, Spring doesn't let us get this application up and running so that we don't encounter into any issues in the runtime and environment. For example, let's say in a production environment where you definitely don't want and need real life problems. So I'm going to go back and fix this now. I'm going to also have to delete the second E here. I'm also going to remove these unused imports and get my application running. Now that everything seems to be fine and we have a Spring Boot application up and running, I'm going to go ahead to my Postman and see actually if this new API that we just created actually work. So I'm going to click and create an HTTP because we are going to be connecting, we are going to be interacting with our Spring Boot application via the HTTP protocol. And I'm going to set post as the HTTP verb here because if you remember, we had annotated this particular Java method with the post mapping annotation, and we had to use the books address. So in the URL, I'm going to type in HTTP semicolon / localhost 88, and finally we are going to have safe users. And now I was going to go to the body section, but this is all nice and good until you have 5 or 6 or maybe 10 different parameters that you have to take in. And this is where object-oriented design and object-oriented programming steps in. When you have certain group of fields that you are going to always be using together because they actually all together form a real-life object, let's say in this case a book, then you can use Java classes to encapsulate their basic functionalities in just one class. So what I'm going to do is I'm going to create a package. Actually, I'm going to do it right here. I'm going to call this model. You can also call this DTO based on your, again, project standards. And I'm going to create a Java class that is going to be called create book request DTO. And DTO stands for data transfer object. And I'm going to open these side by side so that we can cheat a little bit, if that makes sense. Here, I'm going to have a couple of fields, namely the title, namely and it would make sense to write private instead of something else, private string author, and finally we are going to have a private string ISBN. And here in this particular Java method called createBook, instead of taking different parameters which may grow over time and in fact grow exponentially, we are going to be taking an instance of this class createBook request DTO, and I'm going to call this request DTO. And now that we are using post mapping, and you have to know a tiny bit of HTTP for this one, we are going to be using request body annotation so that again, we can declare our intentions to Spring that our clients, the clients of this particular Spring Boot application, they are going to be, when accessing this particular endpoint, they are going to be providing us with a request body that we are going to be, let's say, using here in this Postman application. And now what we also have to fix is that now here, instead of title, we need to say something like request DTO get title. So for that reason, I'm again going to use the convenient Lombok annotations called getter and setter. And here on the left-hand side, instead of title, I'm going to say request DTO.get title and request DTO.get author, request DTO.get ISBN. And one smart question would be that, okay, we have used getter annotation because we wanted these get methods, but why did we actually use this setter annotation? I don't see anywhere where we explicitly use set methods such as set title or set author. But the thing is, Spring, as magical as it seems, it is not magic. It is basically a pre-written collections of code that you can use conveniently. So if you were to implement this request body, or if you were to implement this REST API yourself, you would have to use setter methods to bind the request body and the parameters in that into your Java class, or particularly the instance of the createBook request DTO Java class using those setters. So Spring under the hood is also going to need them. Again, it is as magical as it seems, it is not magic. So if I, again, rerun my application now, I'm going to go back to the Postman, and here I'm going to use JSON so that we can have a more visual, more beatified version of what we write. Here we are going to have to specify a title. I will say title 1 because that's how creative I am. And I'm going to say, as you can guess, order 1. And then finally, in the ISBN field, I'm going to be much more creative and say something like 1-2-3. And if you think this is not as creative as you might wish for, I totally agree. I have nothing to argue against it. So what I'm going to do is I'm going to send this request, and right away we are going to be getting a 404 HTTP status, which stands for resource was not found. And right away what I see is that instead of books, that was the initial URI for our particular API, I typed in users, and that this was honestly not intentional. And I'm going to fix that now and write the correct URI, which is books again, and retry this one. And if I go back to my terminal and rerun the select query to see if that worked, we now see this IDs and authors, and we basically have a new book in our book table. And practically speaking, this now works, but one of the most urgent problems that we are going to need to solve in this particular application is that in Spring Boot applications, in real life projects, you have 3 layers at the very least, which are controllers, services, and repositories, and they each have different purposes of existence. And without diving deep into the theory, what I can tell you in as a recap is that controller is supposed to be defining APIs and taking inputs from the client to delegate that to the service layer. And then the service layer is supposed to be conducting checking for certain business workflows, business rules, and where necessary, it should delegate the database related operations to the repository and then take the feedback from there and return it back to the controller so that controller can again respond to client of this application, client of this, let's say, particular API with the response that service layer created. So what we are going to have to do is to introduce a new class called book service. And we already have created the service package. And here we are going to have both of these book services and controllers side by side again so that we can work together. And now here we are going to have to annotate this class with a service annotation. You can also annotate this class with a component annotation, which as you can see here, if we go into the service functional interface, although they achieve the same thing for you, which is enabling dependency injection and inversion of control, this is a meta annotation as they would like, as the Spring developers would like to call it. And this is a better way to annotate your classes so that it is more readable and clear, if that makes sense. So here, instead of having this book repository over here, we are going to have this here. And right away, we are going to have to create the constructor for this book service. And finally, we are going to create a new Java method called createBook that is again be returning a book entity. And this is also going to be taking a createBook request DTO as a parameter. And instead of having all of this construction logic in the controller layer, we are going to take that into the service layer so that our controller layer becomes much more easier to read and understand. And it only has one responsibility, that is to delegate the responsibilities to the service layer and then communicating back with the client. Obviously, now we are going to need an instance of this book service now instead of the book repository. And down here in the all arguments constructor, we are going to be initializing the book service rather than the book repository. And I'm going to remove this unused line, and we are going to be returning what the book service dot create book method returns when it takes this particular DTO as an input. And now if I run my application again, I hope everything is going to be fine again. So we have seen the start library application log. I'm going to go over to my Postman, and as you might expect, I'm going to use title 2 as the title, author 2 as the author, and then make a slight change to this ISBN. And when click on send, we are still going to have the same functionality. If I go over to my terminal and execute the same query again, now this time around we are seeing 2 different rows, 2 different books. And you might be thinking, if I go back over to my IntelliJ, we used to achieve the same functionality with just 2 classes, actually 1 class and an interface, but now we have an extra layer. Isn't this just redundant? And the answer is a very hard no. Because again, if you are developing a school project, if you are developing a project for your college assignment, then you are going to have just a couple of services and just a couple of entities and repositories, and it is going to be fine. Whatever you do is going to be fine as long as it works. But in real life projects, you are going to have tens of different of services and controllers and repositories, and probably hundreds, if not thousands, of different Java methods. So it is extremely helpful to separate the concerns of certain layers and classes. Now, the last thing I would like to do is that remember that we had imported the Lombok library when creating this class, and we actually used that in various places, such as in this book entity, we use the getters and setters. What we can actually do is that instead of retyping these constructors every single time, we can actually annotate this class with a required arguments constructor annotation, which again comes from the Lombok package. And this is going to achieve the exact same thing. And I'm going to do the exact same thing over here as well, and rerun my application just to make sure that everything works. And I'm going to go back to the Postman, and as you might expect, this is going to be title 3, author 3, and 1, 2, 5. And if I click on send, now this time around we have an ID of 52, which is actually quite surprising for me as well. So I'm going to execute the same query. This actually took me quite a lot of time to really understand what happened here. And I really wanted to share this learning moment for the all of you, so that I decided not to cut it out. And instead, I'm going to explain what happened and why it happened. So if we go back to our book entity, as you are going to remember, we had annotated the ID field of this book entity with a generated value annotation. And if you paid attention enough, we actually mentioned certain generation types, and we actually used the default automatic generation type strategy for this particular entity. Now, to my surprise, this was actually different than the internal working of this was actually quite different than what I thought. And what I found out is that when I was searching for this over the internet, is that when selecting generation type auto with MySQL, I don't know if that's also the case with other relational databases, but at least for the MySQL, when we set the generation type as auto, instead of delegating the responsibility of ID creation to the database application, in this case our MySQL server, Spring Framework, particularly Hibernate, undertakes that responsibility of creating IDs. And how it achieves is that every single time we run a line of code such as this one, as you can see here, BookRepository.save, basically any saving persisting operation, in that case, Spring Framework, instead of us having to do that manually, it goes to the database and asks for the next available ID, and it comes back with it and creates the entity and then goes back to the database again to persist that entity. But in order to make this efficient, it doesn't go ask for IDs every single time. It actually by default uses a batch size of 50. And what it does is that, for example, we are creating a new entity and we just recently started our application. The memory of our application is fresh. And let's say we only have one row in our table with the ID 1. So the next time we run this piece of line, in this case, this line 20, Hibernate actually not only asks for the next ID, but also reserves the next 50 by default. But I think you can change that using your application properties or application YAML files. So what happened here is that I'm no longer going to be able to show you the ID 52 because I had to try out a lot of different API calls here. But the reason we got 52 here instead of, as if I'm not wrong, 1, 2, 3, or either 3 or 4, is that we had created the second book entity when our Spring Boot application had a fresh memory. So when it went to the database application, it actually reserved the next 50 of them. But as you can remember, after implementing this required arguments constructor annotations rather than the constructors that we had written manually, or in fact using the IntelliJ's built-in tools, I decided to rerun the application, which actually refreshed the memory of our Spring Boot application, but the database didn't know about it. All database knew is that Spring application came to me and it reserved the IDs from 2 to 51. So the next time I rerun this application, what happened is that our Spring application, Hibernate, had a fresh memory. So when we tried to create a new book, it actually went to the database and again tried to reserve the next 50 IDs. But in that case, that wasn't 4 to 53, but instead from 52 to something. So what we are going to do is that instead of using the generation type auto, we are going to delegate the responsibility of ID creation to the database application. So I have already dropped our table and I'm going to clear this one. I'm not sure if this works. Okay, it doesn't. I'm going to spam some command L to clean it up and stop our application. So what I'm going to do is that I'm going to specify a certain strategy, and that strategy is going to be called identity. And this particular strategy is going to assign the responsibility of ID creation to the MySQL server. And if you remember, I had dropped my book table in the Spring Boot application, but just to make sure I'm going to execute this query, okay, maybe I wasn't, and then I'm going to drop this one again. Now, if I try to execute the select query again, we are going to see a table doesn't exist error. Now I'm going to clean this up and move over to application YAML. And for a moment, I'm going to change this property create so that when our Spring Boot application gets up and running, it can also create the necessary database table for us. So right away, we see that our library application has started. And if I go over to my terminal and execute the same query, this time around, we don't get any warnings. But now the difference is that when I go over to Postman and create a couple of books that are exactly the same. Now, this time around, we are going to be getting an ID of 1, and then 2, and then 3. And this is obviously nothing surprising. But the difference is that if I now rerun my application, we are not going to be picking up from 50 something, but instead, now that we have delegated the responsibility to the MySQL server, it is going to handle that in a way that we would actually expect as human beings. And all right. And that surprising ID1 is the exact reason why you don't need the auto creating your application. So I'm going to change that one, and I'm going to rerun my application one more time, and one final time, at least as I hope so. So in order to actually, no pun intended, validate my table, I'm going to go over to my MySQL server, and now we have only one row in our table. Now, what I'm going to do is that now that we have the validate property for this JPA hibernate.ddl-auto, I'm going to create some new resources, which are going to be 2, 3, 4. And even if I rerun my application, but this time around we have the property DDL-auto as validate instead of create. Now that our Spring Boot application started again, but if I go to terminal and execute the select query again, we still have the same 4 rows in our database. And hopefully this time around, when I sent this API request, we see an entity that has been created with the ID 5 and 6 and then 7, although we had rerun our application and refresh the memory of our Spring Boot application. Now, this has been a painful experience for me as well, but I again decided to not cut it out any of this so that we can learn together with our mistake. And actually, in a way that both me and you have now understood the main reasons why we don't use the DDL auto create in our applications. That's also a plus. So all that being said, I am going to go back to my Jira task. And if we remember, we were supposed to create a full-fledged CRUD application for this book entity. And we have started with the create, and that works just fine. Now, the next logical step would be to be able to retrieve this data. And here we have 2 APIs that we need to implement. First one, or in no particular order. First one is that we are going to need to be able to retrieve a certain book entity by its ID, and we are also going to need to implement an API that is going to enable the clients of the Spring Boot application to retrieve the entire list of books. So without further ado, I'm just going to hop over to IntelliJ, and I'm going to close this one, and this time around, I'm going to start with the book controller. So again, before diving deep into any single annotation, I'm just going to write a simple Java method, and in fact, 2 Java methods that I described just now. First one is going to be returning a book entity, and I'm going to call this one getBook. And as a parameter, it is going to take a book ID, or you can also call this ID because we are already in the book controller. And the name of this method is also getBook. And the second Java method that we are going to create is going to be returning a list of book entities this time around. And actually returning entities in your APIs is not ideal. It is in fact an anti-pattern, but we are going to get to that. If I'm not mistaken, that is our last task in our Jira board. So I'm going to have to import the list interface from the Java util package, and I'm going to call this method getAll or getBook, potato. And this is not going to be taking any parameter for now because this is going to be returning every single book available in our database application. So just like we did with the book creation, we are going to delegate the responsibility of retrieving a book to the service layer and keep our controller nice and clean. So I'm going to say .book service get book, and I'm going to try to call that with the parameter ID. But right away, our IntelliJ application is going to tell us that there is no such thing as in the book service. And if we go to the book service, there is only one single Java method that is called create book. And there are 2 ways to go about it. You can start to write this exact same method signature here. But what I find more convenient is that I'm going to hover that red line and click on create method getBook in the book service. So this time around, the repository method that we are going to need is the find by ID method, which is going to be taking a parameter long ID and is going to be returning not a book entity, but an optional object of a type book entity so that we are actually enforced to handle the case where this particular entity might not exist in that database application with that particular ID. So if I try to say BookRepository.find by ID and say return, as you can see here, if I try to rerun my application, this is not going to compile. And the reason for that is now different, but the thing is, if I comment out this one or simply say return null here, and I'm going to annotate this with to do implement so that we don't, not that we are going to forget it, but this is already a good practice. Even if you are developing projects for a, let's say, a job interview or let's say a university project, this is still imperative to get used to doing these things, because when you start actually working as a Java developer and you have like tens of maybe 20, 30 different of changed files in your workspace, you are going to forget what needs to be actually done. So this is a good practice. And now I'm going to go back to book service again and try to rerun this application. I didn't have to go to the book service, just to be clear. Now the problem we have here is that our ID is warning us about that there is an incompatibility issue. It was expecting an optional of book entity, and I'm going to close this down and go back to the book service, but we tried to return a book entity. So there are two ways to go about this. First one you can do is, which is not the most clean, most readable way, you can, but this is more easy to use and remember. You can assign the object that is going to be returned by the book repository find by ID method to an optional book entity and call this, let's say, optional book entity. And you can handle it like this. If, let's say, optional book entity is empty, which is a method that comes from the optional class, and this implementation itself, return value equals null, seems extremely simple, and it is in fact simple. But optional class makes it imperative, makes it required to handle those edge cases. So this is its advantage apart from certain capabilities that we are going to actually use now. What you can say is if this is empty, you can either return a null or maybe throw an error, which would probably make more sense. Let's say throw new runtime exception, book not found. And if not, if the optional book entity instance is not empty, then you can return optional book entity.get, which is, as you can see here, going to have a return type of book entity. Now, there are actually better ways to do this. Let's start with the returning null. Instead of doing this, what you can do here, and I'm going to comment this out so that we can reference it and then compare it side by side. What we can do here, return optional. Okay, this time around we don't have an optional, but instead we have book repository find by ID, and then we can say or else null. And what this convenient or else method in the, again, optional class is going to enable us to do is that we don't have to write certain if else logics that is going to take up time and space. We can simply say, okay, find this by ID. And if this book entity is present, return that. But if not, then you should return a null. And instead of returning a null, if you would like to throw a new runtime exception, you can use the or else throw method and a lambda expression to achieve the same functionality, which would look like this. And we are just going to type in new runtime exception and again, book not found. And this is going to work the exact same way. So I'm going to delete these now and actually get my application running so that we can test it. And I'm going to remove this unused import now that we have time. And if I go back to my book controller, okay, one thing I missed is that now again, this is just a regular Java method that has no access from the outside web. Now, just like we have used the post mapping annotation up here for this create book method to make this particular Java method accessible from the outside web, we are going to have to do the same or maybe a similar thing. And this time around, this is not going to change any resources in our database. So this is going to be a get mapping. And just like that, you can also, again, use request mapping. And then for the request method, you can set it as get. And this is going to achieve the exact same thing, but it is going to be more verbose. So I'm going to go back here and specify the URI again. And we are going to be taking in a pet variable. And just like in the createBook method, we specified that this DTO is going to be presented by the client as a request body. We are, as you can see here, this is a pet and this is a variable. So we are going to have to annotate this method parameter with a pet variable annotation. And now if I run my application and see everything is fine, I'm going to go ahead to Postman and create a new space where we can send a new HTTP request. This time around, the verb is going to be get. And again, we are going to be calling HTTP localhost 88 the book. But if you remember our pattern, we are going to have to specify the ID of the book we are looking for. So let's say we have, okay, I'm going to clean this up again and execute the exact same select query. We have certain books here that have the exact same properties. So before trying it out, I'm going to create another one with a different title like this. I'm going to send that and make sure that it is in our database. Okay, now if I go back to this one and try to access the first book that we have, or more particularly, technically speaking, the book with the ID 1, and if I click on send, again, we are going to see a not found. and I'm going to go back to IntelliJ, and I'm going to realize for some reason I again typed in users instead of books. So I'm going to rerun this now. I have actually no idea why this happens over time. And I'm going to go back to my Postman and try to fetch that data. And as you can see here, this is going to be the exact same as our first row. And now, for example, if I try to access the book with the ID 8, now this time around we are going to be getting the last book item that we just recently created. And last but not least, if I try to access a book that doesn't exist and click on send, this is going to be returning an internal server response, because if you go our IntelliJ, the way we implemented this method was that if it's not found, we wanted it to throw a new runtime exception. And that is exactly what it did. It threw a runtime exception with the log content book not found. So in a nutshell, this was the first API that we needed to implement. And the second is that, as we can see here, is the getBooks API. Now, first of all, I'm going to annotate this with getMapping again, because this is not going to change anything in the database. So this is just a read-only operation. And this time around, we are going to use /books, not users. And then we are going to be returning book service, get book. And right away, we are going to see the exact same warning here that this method does not actually exist in our book service. So I'm going to create that one. And this time around, the repository method that we are going to need is going to be called find all. And as you can see here, this is right out of the box going to be returning us a list of book entity. And we are going to have to be returning this list instance that is going to be list of book entities that is going to be returned. And if I'm not missing anything, that is everything that we have to do here, because we are not taking any parameters either. So I'm going to rerun the application and move over to Postman. Now, instead of with a particular pet variable, I'm going to try to fetch every single book that exists in our database application, in our MySQL table. And now we are going to see all of this that matches the exact same rows in our database table. And before continuing with the update and delete mapping, what I want you to realize is that we actually had to write books and books and books over and over again. And this is not the end of the world, but it would be much more cleaner if we didn't have to rewrite this over and over again. So what you can do is you can actually annotate this class with a request mapping annotation. And then here, as you can see here, we are still going to have a path that you can use to specify the general URI for this particular controller, or more particularly, more technically speaking, the endpoints that are going to be contained in this particular controller. And I can type in book, and now I can actually delete these two. And for the get book method API, instead of /book/id, I can type /id. Okay, whoop, I can remove the books part, and all of these APIs are going to infer the books prefix for their URIs. And just to make sure that this works, I'm going to rerun the application again. And having seen that the application has started, I'm going to go back to Postman, and let's say I will try to get the book with the book ID 8 again, and this is just going to work fine. Or if I try to get all the books again, this is going to fetch the exact same data. So that's good to know. Okay, now I'm going to go back to the Jira task to make sure that we are not missing anything other than the update and delete functionalities. Okay, we have created the book entity with certain fields. We have implemented the repository layer. We have created the REST APIs for adding a new book, getting all books, getting book by ID. Now we have the update book details and delete a book method, or more particularly functionality. So in order to make sure that we have everything in one place, I'm just going to type in some to-dos here, implement update functionality, and then I'm going to type in another to-do item that is going to be implement delete functionality. And I'm going to start with the simplest one of these two, which is the delete functionality. What we can do here, we are going to have, again, a basic Java method that is not going to be returning anything, and I'm going to call this delete book by ID. And this is again going to be taking a long ID. And this is going to be calling the book service delete book by ID using that ID parameter. And note that we are not going to be returning anything, because the return type of this Java method is void. And I'm going to create that one. And actually, I'm going to come back to the book controller. So what we have to do here is that we are going to have to annotate this Java method with a delete mapping annotation. And just like we did here for the get book, I'm going to tag that in here and annotate this long ID argument with a pet variable annotation, so that Spring Web can handle the rest for us. And here here in the deleteBookById method, I'm going to look for the repository method that is going to help us delete by ID. And as you can see here, its return type is also void, which is a technical and fancy way of saying that it is not going to be returning anything. We are going to be calling that method. And again, do you realize that we are not using the keyword return because this method is not supposed to be returning anything? And again, if I'm not missing anything, this is everything we got. That's why I said this is the simplest one of the two. Now, in order to be able to test this API, I'm going to jump over to Postman and click on New to create a new HTTP request. And as you might suspect, this time around, our HTTP verb is going to be delete, specified by this delete mapping annotation. And for the URL, we are going to use the exact same one that we used for getting a book by its ID. So in order to make sure that we can trace what happens, I'm going to clean all of this and execute the select query. And now we have books with the IDs ranging from 1 to 8. So if I go ahead and try to remove the book with the book ID 7 and click on send, now this time around we are not going to be seeing any response body down here, because if you remember, and I think you are going to remember because I mentioned that way too many times, this method has a return type of void, which means that this is not going to be returning anything. But it doesn't necessarily mean that it doesn't do anything. If I go over to terminal and remember that we had tried to delete the book with the book ID 7, now if I execute the same exact query, this time around we have books with the IDs ranging from 1 to 6, and then we have the book with the book ID 8. Now, one thing that is worth mentioning in that, in real life projects, delete mappings, or more particularly deleting resources from your database application, is not a common practice. It definitely is useful to know how to implement these, but most of the time, for regulatory reason, for certain technical reasons, you usually do not delete resources from your database. And instead, what you do is you add some certain field in your table, such as is active, or let's say is deleted, or is passive, something along those lines. And you change that property so that you can filter them later on when you would like to fetch the books that are actually going to be useful to you, not the ones that you actually want to be deleted without actually having to delete them, if that makes sense. Now, last but not least, we are going to have to implement an update functionality. And the reasoning is quite simple. What if I mistype the ISBN or the title of this particular book? Do I have to recreate it? And the answer is probably not. I just need the capability of changing certain properties without re-entering every single detail for that particular resource. So for this particular method, we are going to be using put mapping annotation. You can also use patch mapping annotation, and there are a very slight, very minor differences that if you want, you can explore on your own. But again, to be perfectly honest and transparent with you, in most of the real life projects you are going to encounter, unless you are working for Netflix or Google or some other company with brilliant minds, most of the time you are just going to be using get mappings for the APIs that are going to retrieve data that are not going to change any resource in your database, and for the rest you are going to be using post mapping. And in fact, I have actually seen pretty good engineers actually use post mapping for endpoints that really need to be annotated with a delete mapping annotation. But if you are working for a business, for a company, for a profit-oriented company, these are not usually the concerns that people pay attention to much, again, to be as transparent as possible. I'm going to use put mapping here. And again, we are going to take an ID. And do you remember that the prefix books is going to be inferred thanks to the fact that we have annotated this book controller class with a request mapping with this particular URI. And this method is going to be returning a book entity, which is going to be the updated version of the final entity. And I'm going to call this method update book with the parameter long ID. And again, we are going to have to annotate this argument with a pet variable annotation, so that the Spring Web knows that it should bind this variable to this particular variable we have here. And in the body, I'm going to be returning book service dot update book with the parameter ID. But now, in addition to the ID, if we come back to our table, we need to be able to update certain fields of these rows, such as author, ISBN, and title. So we are going to have to take some input, some optional inputs from the client of this application. And for that, we are going to use the request by the annotation again, because by the HTTP standards, when you are using put mapping or post mapping, as you might remember here in our CreateBook API, the way you take in parameters from your client, the way you communicate such information is body of an HTTP request. So I'm going to type in request body. And again, this is a matter of taste. You can actually use the exact same DTO. And let's say this is named book request DTO instead of create book request DTO. And you can use that here in a way that you can rename this as, again, book request DTO and then pass that in. And this is going to assume that both update and creation APIs are going to have the exact same fields that are going to be needed for those particular APIs. But the way I see is that those are two separate classes. Those need to be two separate classes because of the idea of separation of concerns. Even if they're going to be the exact same from a content perspective at this particular moment, it is not guaranteed that they're going to be the exact same 3 years from now. So some people may argue that, okay, whenever that's the case, then you can split the classes, and I don't have much to argue against it. But the way I do it is actually creating separate request DTOs for update and create APIs. So I am going to rename this to create book request DTO again. And here I'm going to find this DTO and create a new one called update book request DTO. And right away, I'm going to annotate this class with Lombok annotations getter and setter. And I'm going to take the fields with me to the other DTO as well. So if I close these down here in the update book API, instead of using the create book request DTO, I'm going to be using update book request DTO, and it is going to make me import the class. And I'm also going to have to name this variable as request DTO. And finally, I'm going to create the update book method in the book service. And here, what you are going to do in this method is that, first of all, you are going to get the book entity using the find by ID method of this book repository. And I'm going to look for the find by ID method. And again, this is going to be returning an optional of book entity. So I'm going to throw an exception if there is no such book. Or alternatively, what you can do here is that you can end this line with a semicolon and change the return type of this variable as book entity, optional book entity, and rename this and say, okay, if optional book entity is empty, then I'm just going to return null. And if not, I'm going to conduct operations. This is going to be, your API is going to be returning a success response with a body, with a request body that is going to be null. Also, you are going to be returning a success response, which I don't really want. So I'm going to go back to my older implementation, my initial implementation. And if the book is not found, I'm going to throw an exception. So now we are going to use the request DTO to set fields here. And then after we change this book entity object we have retrieved on the line 40, what we are going to do is we are going to return book repository.save book entity again. Now, the only difference with the book creation is that we actually had initialized the book entity object from scratch, but this time around, we are getting it from the database using the Spring Data JPA. Then we are going to be changing some of the fields, and then we are going to conduct the exact same save operation. And one thing you should realize that, and I'm going to open this update book request DTO side by side with our book service so that we can see them both. And I'm going to make this a little bit narrower. Now, on the right-hand side, do realize that there are no validations available in this DTO. So all of this might as well be null, but I'm not sure if you really would like to set nulls to your entities. I mean, that might be your choice. That's a design choice. But the way I propose, the second way I actually propose is that you need to be checking for null values by either saying if title is not equals to, request DTO get title is not equals to null. Then we are going to set the title field of this book entity with this requested title. And now do you realize that for a single property, we had to write 3 lines of code, and imagine that you have tens of different fields in your request DTO, and that is going to be a messy book service method. And again, this is a design choice, but let's say I decided that none of these values in this update book request DTO are supposed to be null. What I can do here is that instead of validating these fields in the service layer, I can actually use certain annotations that are going to enable our application to validate those fields before we take the object into the controller layer. And to be able to have access to those convenient annotations, we are going to need to have a validation dependency in our project. So if I picked out validation here, what you're going to see is that, and we are not going to recreate the project every single time we need to update the dependencies. And here realize that if I were to edit this beforehand, the Spring Initializr would have given us these 4 lines so that our project build tool, which is Maven in this case, would download the required dependencies so that we could use those annotations, the convenient annotations. So I'm going to go back to the IntelliJ and find my POM.xml class, which again stands for Project Object Model, which is the basis of your Spring Boot application. And I'm going to add this dependency under my own dependency. And right away, IntelliJ is proposing us that we should synchronize the Maven changes, which is a technical way of saying that we have added a new dependency, so we need to download the content of that particular dependency. And right away, you are going to realize that we no longer have a red line here. And now if I come here to update book request DTO and I'm going to make this full size, I can now actually annotate this field with certain annotations such as not blank, which we are going to be using for strings so that they are not null and they are not blank. And if you are curious about what is also there for you, you can also see here that there are certain convenient annotations that you can use for, let's say, Boolean values such as assert false and assert true, or an email annotation that is going to validate an email if a string is an actual email with ats and dots in it. It is going to enable you validate certain integer values, nulls, not nulls, and certain regex patterns, etc., etc. But in this particular case, all we need is going to be the not blank annotation, and I'm going to annotate them all with this particular not blank annotation. So now in the book service, I don't have to check for nulls, because if any of these fields are null, this is not going to be ending up in the service layer anyways. So what I can do here is that I can simply set these values, book entity set author, request DTO get author, and finally we are going to set the ISBN of this entity using the ISBN that has been provided in the request DTO. So I'm going to rerun this application now, and I'm actually going to remove this to-do item here so that it remains clear and readable. And if I go back to the postman now and find one of the post methods actually, so that we can have a body ready for us. Now do realize that in the controller layer, we have used the put mapping annotation and we need to specify an ID. We are going to select the put as the HTTP verb. And let's say I would like to change the book with the book ID too. And just to make sure that we know the exact last state, I am going to run the select query again. And for this moment, we have a book populated with these certain fields. Now, what I'm going to do is that instead of author 1, I'm going to use author 15 and title 15 as well. And for this ISBN, I'm going to make up another value. And actually, before running that, I'm actually going to delete ISBN. And when I click on send, I was expecting an error, to be honest with you. And I'm going to go to my terminal to see, okay, this has been updated. And this is a common gotcha point in Spring Boot validation. Just because you annotated your fields with certain annotations that come within the validation constraint package, and if you are using Java 8, this is going to be Java X rather than Jakarta, just so you know, what you're going to have to do is that you're going to have to annotate this request body field with a valid annotation that again comes from the Jakarta validation package, because otherwise Spring is not going to be able to conduct the constraint checks on your behalf. So I'm going to rerun this application again and move the postman this time. And now I'm going to change these two values to 16. I try to click on send. This is in fact going to tell us that this is a bad request. And what bad request basically means is that, and do remember that last time we had internal server error with the HTTP status code 500, which means that there has been something wrong within the system. And in that case, that was because the server was not able to find the book with the ID 81. But this time around, the status code is not 500. It is actually 400 with an error bad request. So what this in the simple sense means is that the server is fine, but your request is not. So you have to rewrite your request, because otherwise the server is not going to take you seriously. And if we go back to the terminal and execute the exact same select query again, you realize that we still have author 15 and title 15. But if I move in here and add an ISBN field to this request body, and I'm going to make up a value and try to update the book entity with the book ID too, now this time around, this is going to be working just fine. And if I hop over to my terminal and re-execute the exact same query, now we are going to see that this book with the ID2 has been updated. And by that, we actually have all of our Java methods that are going to serve us as APIs, as endpoints, as entry points to our backend applications are actually complete now. We have the creation API, we have the APIs that are related to read operations, we have the update operation, and finally we have the delete operation, which is again called CRUD if you take the initials of these HTTP verbs. So I'm going to go back to the Jira task just to make sure that we don't miss anything. Okay, we have implemented the update book details, delete a book functionality, and then we have tested these APIs using Postman. And this is the moment we earned the privilege of moving this task to done. But our project is actually unfortunately still far from being a good application from a design perspective, from a technical perspective. So we are going to have to continue. Next up, we have the Jira task that is related to implementing a pagination feature for the book listing API. And the idea behind that is actually simple. If I go over to my Postman and find the one where we retrieved all of these books, here do you realize that we are retrieving every single book that exists in our database. But again, if you're developing for a university project or some sort of personal project that you try to refine your skills, this is going to be fine. But if you are going to work for a real project, for example, in a library management system like this, you are not going to have 8 books in your system. You are going to have thousands of them, maybe 10,000s, if not 100,000s of them, and you really don't want to fetch them all because that is going to be detrimental to your database application's performance. That is going to be detrimental to your Spring Boot application's performance, and it is probably going to take down your front end or any other client that is going to connect to your Spring Boot application as well. So ideally, what you would like to do is to implement a pagination feature so that all of the entities, all of the rows in your database are accessible, but not once at a time. Instead, for example, your front-end application can request 20 books at a time or 50 books at a time, and therefore the system does not crash just because someone tried to refresh the page just only 3 or 4 times. So I'm going to go ahead to IntelliJ IDEA, and first of all, I'm going to show you some basic JPA repository methods that we are going to be able to use for this particular feature. Now, do you remember that as I was typing find all, we had seen several methods that are available within this JPA repository, and one of them is actually taking a pageable object as a parameter, and it is going to be returning a page. Now, there are a couple of ways to get a pageable object, or more particularly an object from the class that implements pageable interface, and I'm going to get to that and make it as visual as possible. One of the things that you can use is the page request of method, and here you can specify certain page numbers and page sizes and get a page request object. And if you go inside this page request class and then to the class that this page request class extends, what you're going to see is that this is a class that implements the pageable interface. So that means if you were to create some sort of page request here, let's say with page number 1 and page size 10, you can actually use this variable as a parameter to this find all method. And right away, what you're going to see is that when I go into this method, this is a method that comes from the paging and sorting repository. That is again comes from the Spring Data dependency. And you might be saying, I don't recall implementing any sort of paging and sorting repository, but JPA repository actually did that for you. So if I go back to the book repository interface that we created, this is an interface that extends various other interfaces. And if I go inside this list paging and sorting repository, it extends paging and sorting repository, which provides us with this beautiful repository method that we can pass in a pageable object, or more particularly an object of type that implements this pageable interface. It is going to return us a page object with certain features. So I'm going to go ahead and demonstrate now For example, we are going to be using page number 1 and page size 5. And do you realize that this method is now going to be returning a page of book entity instead of a list of book entities? So I'm going to have to change this one as well as the return type of this particular method. And now we have a couple of errors. Okay, I was supposed to write page instead of page request. And then here we have no warning. So if I run my application, and obviously we are not going to leave as it is right now. We are not going to be using static values, but rather we are going to be taking parameters. But first I would like to show you how this works. So if I go over to Postman, and this time around, if I would like to get a list of books, and I forgot that the page request objects are 0 index. So even though the page number is specified as 1 here, we are actually, from a human being perspective, we are getting the second page. So I'm going to fix that so that it is easier for us to understand what we are working with. And I'm going to go back to my Postman and send the request again. And this time around, we are going to be, and let me open up our database application as well. We are going to be seeing 1, 2, 3, 4, 5 pieces of information for books. And not only that, but also we are going to be seeing some metadata such as the page size is 5. And if you are wondering, there are 7 elements in total. And it also does the math under the hood and states that there are 2 pages that you can look for. But obviously hard coding this page number and this page size does not make any sense. I just wanted to show you that we need some sort of page request or any other object of a type that implements pageable interface. What you can do here is that you can easily type in pageable, and again we are going to be using the one that is under Spring Data package, as you might suspect. You can type that in as a parameter and then pass that in into your service layer like this, and we are getting warnings because the book service method we have here called getBooks does not take any parameters, so we are going to have to fix that too. This is now going to be taking a pageable object as a parameter, and instead of this hard-coded one, we are going to be passing in that pageable object that we are going to take as a parameter in this API. So if I rerun this application now and move over to Postman, and under this parameters tab, I'm going to specify 2 keys, namely the page key and the size key, which are going to be your query parameters. And for the page, I'm again going to use 0. And this time around for the size, I'm going to use 3 as the value. And if I send this now, do you realize that we got 3 pieces of information for 3 books, and we are seeing certain metadata such as the page size was 3 and the total elements are still 7. But this time around, we have the total pages of 3. For example, if I now increment this by 1, then we are going to be seeing the content of the second page. Or for example, I type in 0 as the page, and for the size I say, I don't know, maybe 50. And this time around, we are going to be getting all the books available in our database because the page size exceeds the number of total elements that we have in our database application. Now with that, I'm going to jump over to Jira and see if I missed anything. All right, and I'm going to skip sorting part on purpose. That is going to be a subject for another video. But what I'm not going to skip is that the default pagination applied when parameters are not provided. So in this case, if I don't send any of these keys and send this request, do you realize that Spring assumes some sort of default values such as size equals 20 and the page equals 0. But let's say I don't want to be at the mercy of our client or Spring Boot's defaults, and I would like to specify defaults myself. What I can do here is that I can go back to my book controller, and just like, for example, we annotated this long ID field with a pet variable annotation, or this request DTO with a request by the annotation, I can annotate this field with a pageable default annotation. As you're going to see here, we are able to apply certain size and page default. So I'm going to go back here, and for the size, I'm going to set 5, let's say. And just to make sure that it works, I'm going to specify the page as 1, which you would not really do in a real life project. But in order to be able to see that this works, I think this makes more sense. I am going to rerun my application now and go over to Postman. And when I now resend this HTTP request, now in this metadata, we have the page size 5 and page number 1, which is again in a 0 index world, should mean the page 2 for human beings. We are bypassing the first 5 rows in our database and only getting the second 2. But nevertheless, I am still able to overwrite that default. And if I, let's say, would like the first page with the size 50, then I'm going to have exact same response that I had before implementing the pageable default annotation. And with that, we actually, again, deserve the right to move this Jira task to the done column. But again, we are not ready yet. We still have to implement request validation and predefine our API response errors. And we are also going to introduce DTOs to our project so that we don't return entities in our APIs, because entities are directly mapped to our database roles and its internals. So we don't really want to expose everything, but rather the fields that we would like to actually expose. So I'm going to go ahead and start with adding DTOs because this is the easier one. So I'm going to go over to my IntelliJ, and first things first, I'm going to create a new DTO called BookDTO. And just like in the other DTOs, I'm going to annotate this class with Lombok annotations, getters and setters. And let's assume that ISBN, which stands for International Standard Book Number, contains the sensitive data. It doesn't, but let's assume that, and let's assume that we don't want to return ISBN values to the client of this application. So what I'm going to do is to type in private string title and private string author to this class, but I'm going to skip ISBN on purpose. So our next challenge is going to be that instead of returning book entities here, we are going to be returning book DTOs, and here we are going to be using a page of book DTOs, and for the API that is annotated with the delete mapping, is nothing is going to change because it is not returning anything anyway. Now the next challenge is going to be updating the service methods in a way that they also return book DTOs rather than book entities. And the easy part is to change the method definitions. This is as easy as copying and pasting it. But now we have several warnings, several errors, and this is not going to compile anymore because here basically we promise that this method is going to be returning a book DTO, but as of now it is returning a book entity. So we are going to have to fix that in order to be able to get this application compiled and running. Now, there are a couple of ways, if not several, to achieve the exact same functionality, that is to return book entities into book DTOs. I'm going to use the most oversimplified one. And here in this book service class, I'm going to create a new private method that is going to be returning a book DTO. And I'm going to name this Java method to DTO. And again, this is going to be taking in a book entity as a parameter. And now what I'm going to do is I'm going to create a new instance of the book DTO class using its no arguments constructor. And then for this particular DTO, I'm going to set the fields author and title using the entity that is going to be given to this method as a parameter. So I'm going to type in DTO set author, book entity get author, and finally I'm going to return this DTO. And up here in these methods, instead of returning these entities, I can call this freshly created method that we wrote together that takes an entity as a parameter and returns a book date DTO as we would like to have. And right away we are going to have fixed the first method. Now when dealing with optional classes, as we might remember, this find by ID method in this CRUD repository is going to be returning, it's going to be providing us with an optional class. What you can do is, okay, find this by ID, and you can use the method name map and pass the method we just wrote as a parameter. So what these 3 lines of code are going to achieve is that, first of all, it is going to look for that particular table and for particular that ID and try to get the book entity. And if it is able to find and get that book entity, it is going to map to a book DTO and return it as a result of this particular Java method. And if not, as it used to be 10 minutes ago, it is going to be throwing a runtime exception. And I'm going to leave this one to the last. And here we have the updateBook method, in which we can simply take this one and call the toDTO method with this entity that we are going to have. Now, the last warning that we are left with in this class is that particular line 37, in which we are trying to return a page of book entities, but this method is actually expecting us to return a page of book DTOs rather than entities. And in Spring Data, this page interface has a method that is called map, as you can see here. And by using this map method, you can apply certain conversion operations without having to reinvent the wheel. So in this particular case, what you have to do is, just like we map this optional book entity into some sort of DTO, if it exists, by adding just a one line of code, you can do the same thing here. And on the pageable interface, you can call this map method. And just like we did on the line 32, you can call this this to DTO. And now, if I'm not mistaken, we don't have any other compilation issues. I'm going to remove the unused imports that we have in our controller and the service layer. Now, if I'm not missing anything, we have everything ready, and I'm going to try to rerun my application. So I'm going to test these one by one. I'm going to be starting with the getBooks method, and here we are not going to be getting ISBN field anymore. And let's say I would like to get a specific book, and this is going to work just fine as well. Now, if you remember, we hadn't changed anything for this particular API, and we already have tested the functionality for these read-related APIs. So I'm going to have to test the creation and update functionalities. I'm going to go back to my Postman, find one of the post methods, and I'm going to be creating something like this. And yes, we are not going to see any inputs, particularly the ISBN fields that we do not want. And this may not make much sense to you because the client is already providing the ISBN. Why don't we just return it back? But in real life project, this is not always as this straightforward. For example, you might take in a password like this, but you might hash that in your database, and this is no longer going to be looking like this. But you don't want to return the hashed version of your password to your client either. So there is that. And finally, we are going to be testing the put mapping, with which I'm going to update the book with the book ID 1, and I'm going to clean this up. And now we have a book with the book ID whose title is 134, and I'm going to replace that by, let's say, 25. And if I send this now, again, this works just fine. And if I re-execute this select query, this is also just fine. So I'm going to go back to the Jira board. And again, we deserve the right to take this task to the done column. And last but not least, we have implement request validation and centralized exception handling for book APIs. Okay, we actually have started with this one in a way that we added validation to update book mechanism. But now there are two things that are missing. First of all, we are also going to have to implement validation for the creation API. And second, we would like to be returning much more meaningful responses to the client so that, for example, when you're working in a real life organization, something goes wrong, your colleagues should not really have to come to you, call you, and ask you what went wrong, and you have to dive deep into the logs and find what went wrong. Instead, if you return meaningful, proper responses, the clients of your applications are going to be able to understand what went wrong by themselves. So I'm going to take this one to the in progress column, and I'm going to go back to the IntelliJ idea and move over to the create book request DTO. And again, I'm going to be using the not blank annotation for this particular class as well. And this time around, I'm not going to be forgetting to use the valid annotation, and we are going to type that in. So if I rerun my application just to see that this works for creation API as well, then we are going to get to the exception handler. I'm going to go over to Postman, and I'm going to try to create a new book with no ISBN. If I try to send this now, again, this is a bad request. The server is fine, your request is not kind of situation. So what we would like to do is, again, to return a meaningful response. So I'm going to go ahead and create a new package called advice. And in this particular class, I'm going to create a new class called global exception handler. And the implementation of this class is the details of it is something that I didn't manage to memorize in 5 years of professional Java experience. And to be honest with you, I'm probably not going to bother to memorize it ever again, really. So I'm going to go ahead and find a cheat sheet called one of my favorite websites, Geeks for Geek. And here I'm going to find a class that is annotated with the controller advice annotation. So when you annotate a class with a controller advice annotation and you have certain Java methods annotated with exceptional handler annotation in that class, what this is going to achieve is that this class is going to be listening to all your controller methods, your APIs, and whenever an exception occurs, it is going to look for if it should intercept. So if I take that piece of class as an example, and I already have the exact same class name, and I'm going to go back and actually get the imports as well, so that I don't have to import them one by one. And I assume we are going to be needing an error response class that has been implemented around here. So I'm going to find that. And as you can see here, they also use the Lombok annotations. I'm going to take that with me into my project. And instead of an error response, I'm going to call this error response DTO so that it is more coherent with the rest of my project standards. And I'm going to type that in, fix the class name, fix the constructor name. And finally, I'm going to go back to the global exception handler. And instead of error response, I'm going to be using error response DTO. and finally import that class as well. And if I go back to the book service, as you're going to remember, the only case we had explicitly thrown exceptions for was the case that book was not found. So I'm going to go ahead and create a new package under the advice package called exception, in which we are going to have our custom exceptions. And here I'm going to be creating a new exception called no such book exception. You can also book not found exception. This is again potato and potato. This very much depends on your project and organization specific standard. I'm going to create that, and this is going to be extending a runtime exception. And as you can see here in this global exception handler, Geeks for Geeks authors also had a similar exception class. So I'm going to cheat a little bit and see what they have done here by searching for this. And in this class, I'm going to have a field called message, and I'm also going to create a public all arguments constructor by typing in public no such book exception. And this is going to be taking a string message as a parameter. First of all, I'm going to call the constructor of the runtime exception class. As you can see here, this is going to help us construct a new runtime exception with null as its detail message. And then later on, I'm going to set the message of this particular instance to the parameter of this constructor. Now, in the global exception handler, what we can do here is that now we would like this method to handle exceptions for the case there are no such books. So instead of no such customer exists, I'm going to call this no such book exception, as well as here on the method definition. And in the book service, instead of throwing runtime exceptions, I am going to be throwing no such book exceptions. And actually, I can take this message to the no such book exception class now. And maybe instead of string message, I can take the long ID, and I can create a message like book not found semicolon, and I'm going to delete these redundant ones, plus the ID. And right away, we are going to see that the constructor of this no such book exception class is expecting a long value, but we are providing a string. So I am going to pass that ID that we are going to be using here, and I'm going to look for the other runtime exceptions. Here, we are also going to be using no such book exception, as well as the ID that we are going to be using. And now if I try to rerun my application and go over to the Postman to test this functionality, I'm going to start by testing the get API, in which I'm going to try to get a book that doesn't exist in our database. And this time around, okay, we have status code 404, which is not found, which is better than 400 bad request. This is now a bit more explanatory, but I don't know why this is null now. So I'm going to go back to the IntelliJ and find the global exception handler class. And here in the no such book exception, okay, I was supposed to create the getter for this class as well, so that the Spring under the hood can make use of this message value that we are creating on this line 12. And I'm going to rerun the application, move over to Postman, you know the drill. And if I try to run this now, the status code is again what we expected, 404, which stands for not found. And that makes sense because I was looking for a resource and the resource was not found. And apart from that, we now have a more meaningful message, book not found, with the ID such as this one. This works just fine, but one thing that I would also like to fix is that, for example, in this particular case where we try to create a book with missing information, we are still going to be getting a bad request response, which is not as clear as this one. So what I'm going to do is to go back to our global exception handler, and I'm going to introduce another method. And this time around, we are going to be catching method argument not valid exception clause. And the response status is still going to be HTTP status bad request. This is because this is going to be a fault of the client. And now we are going to write the method public response body. Now, again, we are going to be returning an error response DTO with a status code and a message. And I'm going to call this method handle exception as well. But the difference is the perimeter is going to be a type of method argument not valid exception, and we are still going to be returning a new error response DTO, but in this case HTTP status not found dot value, and we are going to be getting the message of this particular exception. And now if I rerun this application and move to Postman and try to resend the exact same HTTP request, this time around we are going to be seeing, okay, I think mistyped the not found. This is not going to be a not found. This is going to be a bad request. I'm going to rerun the application and go back to the Postman right after it started. And when I try to do this again, the status code is still going to be 400. But this time around, we are seeing that there have been an issue regarding the ISBN being blank, so on and so forth. And you can actually create a more readable, more clean response by using the getAllErrors method of the getBinding result of the method argument not valid exception getAllErrors. And then this is going to be returning you with certain object errors. Then you can use these objects to create certain responses based on your project specifications. But for now, I'm just going to skip this one because although this is not ideal, this still conveys the message that needs to be conveyed. So by that, I am going to go back to the Kanban board and try to see if we have missed anything. Okay, we have added the validation annotations to create an update request. Invalid request now return a meaningful validation, well, partially. And we have created a custom exception. We have implemented a global exception handler. We now have a consistent error response model. As you can remember, we have this error response DTO so that our clients do not get different formats of responses every time they encounter an exception. And finally, we have tested the functionality with Postman. We did that with invalid request. We didn't do it with valid request. So I'm going to go ahead and create an actual final book for this particular video. And I'm going to be typing in some random ISBN. And this time around, we are going to have, let's say, order 15. And when I try to create this one and go back to my terminal to see if that worked just fine, as you can see here, we now have this particular book object in our database as a row. And with that, we actually have completed the last item in our board, which was to implement request validation and exception handling centralization. And with that, we actually have earned the right to take this to the done column. And with that, we have completed this particular project. All right, that is it for this particular project. I thank you for your time. And if you enjoyed this video, please be sure to like and subscribe, and I will see you in the next one.